Hi, I'm Steve D'Antonio, and I'm here today to talk a little bit about oil analysis and proper oil sampling technique. There's a lot of controversy about oil analysis. It's often referred to as a black art, pardon the pun. A lot of people don't have faith in it because they don't believe the results, and frankly, I don't blame them, because in many cases the results are suspect. Based on the wide number of oil analysis reports that I see, and when I see professionals taking oil samples, it does give me cause for concern. I lose confidence because I'm not sure that the oil samples that are being drawn correctly, or that the report that's being read is being analyzed appropriately. In many cases, those who are drawing the samples have not been given proper training. Now, the training is not very complex or difficult and doesn't take that very long. And I'll walk through some of that with you here today. But before I do that, let me talk a little bit about what oil analysis is and what you can hope to gain from it. One of the things that I frequently hear people in the marine industry say is that oil analysis isn't very valuable unless you do it routinely and you're getting a trend, essentially. There is some truth to that. However, I would be quick to caution you that a single oil analysis can be incredibly valuable. And while it can offer you the benefit of trending, it can point out a flaw or a defect in the making that otherwise would be invisible to you, to the naked eye, essentially. And a good example of that is an engine that has coolant or antifreeze in the oil or seawater or fuel is immediately a problem or a potential problem, and that's something that you don't want to ignore. If that's a vessel you own, you want to have the problem analyzed and corrected before major damage is caused. If it's a vessel you're considering buying, then you have to think very carefully whether you want to proceed with that, or if you want to have some discussion with the seller about analysis of the problem and correction of it before you actually close the deal, or withholding a reserve to prepare for the potential for repairs once you own the vessel. Don't discount or diminish the value of that, and don't let anybody tell you that oil analysis can't be relied upon, or that a single sample isn't worthy. Now, having said that, if you do take a sample and the results show some anomaly, they've got, as I mentioned, antifreeze or fuel or metal in the oil, it's completely reasonable to take another sample and have it analyzed again, perhaps by a different lab, just to be sure that there's not some issue with the lab. Although that's rare, it can happen. Or you may take two samples and send them to different labs just to be sure that the results are correct. What I would say is that the likelihood of the lab making a mistake is pretty low, but the likelihood of the people taking the sample making a mistake is actually quite high, and that's really where we have the issues, and that's where the training is required. And again, it's not very difficult at all to learn how to do this. It requires absolute cleanliness and adherence to a few key guidelines about how the oil is drawn, how the tubing is put into the crankcase through the dipstick, and how you handle that whole process. Now, on the other side of this equation, we have getting the report back and analyzing it, and that's another area where, regrettably, most people, even mechanics, even very experienced mechanics, are not trained in any way or qualified in any way whatsoever to evaluate or analyze the results of an oil analysis. That does take training, and that type of training doesn't take just a few minutes. It's usually days or more of professional guidance from a specialist in oil analysis, or what's called tribology. So that's really an area where you can run into a variety of problems with folks meaning well potentially by analyzing a report, but in fact not really knowing what they're doing. The common approach with this is for a professional or even a boat owner to look at a report and look for red or yellow indicators of caution or problem, and if they see none of those, then they say the report's fine. And I see this all the time, and in fact that's a very dangerous approach when it comes to oil analysis, because the lab doesn't know as much that you may necessarily know about the engine and the boat and how the sample was drawn and how the engine is used. And labs can only interpret information that they're given, and if they're given information that's incorrect, well, you know what the result is going to be. It's going to be an incorrect analysis. So it's up to you when you're reading that report to analyze it, scrutinize it very carefully to make sure that all of the data that's been provided to the lab is correct. And that includes the number of hours on the engine, the type of the engine, the model of the engine. The number of hours on the oil is critical, and I see that being recorded incorrectly on a regular basis. That can skew results significantly. If the lab believes that the oil has 200 hours on it, because that's what's been written on the report that goes with the oil sample, and in fact the engine actually only has 20 hours, or the oil rather has only 20 hours on it, that changes the results dramatically, because the amount of acceptable contamination that we could have in that oil at 200 hours is far different than what it is at 20 hours. So scrutinize the data that is provided to the lab. Make sure that it is correct. The form that goes with the oil analysis, this type of form, is not very complicated. There isn't that much information to put in on this form. However, if it's put in incorrectly or it's excluded altogether, then again the value of the results of your oil analysis will be skewed, and it could mean the difference between buying the boat and not buying the boat because the results are incorrect, yet they're showing some problem that may not exist. Or they could say everything's fine, and in fact it's not, and then you've then committed to the boat, or you own the boat and you're getting underway for a long passage believing that everything's okay. So once again, the importance of filling out this form correctly cannot be overstated, and the importance of reviewing the oil analysis report once that's received. Make sure that all of that data, once again, that's been given to the lab is correctly recorded and has been transcribed by the lab correctly. And then the actual analysis of the results. Again, that typically requires the eye of a trained individual who knows how to read oil analysis reports and has received professional training on that. The lab can do that to some extent, so you can call the lab and say, I need help analyzing these results. So that's one approach, but learning as much about it yourself as you can is certainly valuable also. Beyond that, doing regular oil analysis does once again give you that option for trending, where you can see the level of contamination in the oil changing periodically, steadily rising would be an indication that something could be wrong or is on the way to being wrong. So there is absolutely a value in doing routine oil analysis and having that record. And part of that is supplying the lab with what's called a reference sample of oil, meaning before you do any oil analysis, you're sending the lab a sample of the new oil before it's ever put in the engine that you intend to use or are using in your engine. So you take the sample just the way that you would from the engine, put it in a sample jar, send it to the lab, indicate that it is a reference sample, it's a brand new sample of oil with 0 hours on it. The lab will then analyze that oil, and the results of that analysis will show up on your report along with the results of the oil that is used. So you can now compare the parameters of that oil with your used oil. So you know what the additive metals are in that oil when you got it when it was new. You know what the total base number of that oil is when it was new, and you can compare it to your readings for your used oil. That is incredibly valuable, and I can't emphasize enough how important that is, yet it is rarely done. So if you're taking regular samples on your own equipment, by all means, provide the reference sample, and that reference sampling should be redone annually because the constituent components in the oil does change periodically, so we want to make sure that we have an up-to-date reference sample that you're supplying with to your lab that shows up on your analysis report. Oil analysis is a very valuable tool. I like to refer to it as the mechanic's crystal ball because it allows you to see through the engine and into the engine and determine what's going on inside when, again, outwardly everything may seem to be fine. And that's one of the reasons that people are often disbelieving of oil analysis results, because the engine's running okay, I don't see any issues with it yet. We're being told that there is a problem or an impending problem. Don't ignore that information. If the samples have been taken correctly and they've been analyzed appropriately, then you've got some very solid information to act on. All right, so let's get started with drawing our oil sample. This is the area where the most mistakes are made with oil analysis. A lack of understanding about the proper technique and the observance of cleanliness for the components that we're working with can and often do lead to erroneous oil samples. And as I mentioned earlier, that can be a problem because it tends to erode the confidence in an oil analysis program for those who are undertaking it. If a boat's being purchased, for instance, or the brokerage folks that are selling the boat, they tend to lose confidence in oil analysis if the results appear to be incorrect, and they often are for a variety of reasons, and often because of the way the sample is drawn. So let's get started. I've got some clean rags here. You'll notice these are cotton rags. They're not paper or paper towels. And you can use a paper towel rag, but you have to be very cautious about having pieces of that paper towel or the lint coming off on the dipstick or anything else that you're putting into the crankcase on the engine. That little bit of lint can end up clogging an oil passage. So if you have a cotton rag that's clean and essentially has been rinsed out, and so there are no little fluffy flakes that are coming off of it, I prefer that. That's actually better than using a paper towel. Again, you can use a paper towel, but if you do, just be very careful that you don't get any parts of it stuck on the dipstick or any of the tubes that were sticking into the oil pan. So we've run this engine, and so it's warm, and that's a prerequisite. The oil's got to be warm, otherwise it doesn't pump, or it doesn't pump easily. And if it's not warm, if the engine hasn't been run, we haven't mixed the oil rather up to make sure that it is homogenized. We want to make sure all the contaminants are in suspension. And if the engine's just been sitting cold for a long time, those could settle out or stratify. So we've run this engine, we've gotten it warm, the oil's mixed up. We're going to take the dipstick out now. I'm going to clean it off. That's sort of typical diesel engine oil. Pretty dirty, looks dirty anyway. It's black. Doesn't necessarily mean it's bad. I'm going to lay that down there. And now we're going to take some tubing that is part of our oil analysis kit, and we're going to take off a piece of it. Let's see if we can do this. Very important that this tubing only be used once. You can never, ever, under any circumstances, reuse tubing when you're drawing samples, because if we do, we run the risk of something called cross-contamination we want to avoid. So one of the most important parts of using this tubing is, how do we know how long to make it? Well, we don't want to take the chance of this tubing running into the bottom of the oil pan and dragging across the bottom of the pan, because it could be dredging up years worth of sediment, and it's going to give us an erroneous an erroneous result rather. So we don't want to take a chance on that. So how do we know how far to put it in? Well, I use the dipstick as my guide. So if I hold this next to the dipstick and I make this essentially as long as the dipstick, I know it's going to touch the oil. It's going to go into the oil. I can go a tiny bit further, maybe an inch or so. And now at the top of the dipstick, I'm going to mark it with a Sharpie. So now I know how long, or how far rather, to stick this in to the oil pan. I know it's going to touch the oil, but it's not going to drag across the bottom of the pan. So now I got to give myself some extra working room. So I'm going to cut it. Okay, so now I've got my tube. Now I need two more things. I need my oil pump, my vacuum pump, and I need my sample jar. So the oil pump, you can see that it lives in this box to keep it clean. We want to make sure that no contaminants enter this area where the oil bottle would be screwed in, because we don't want to skew our results. I'm going to screw, well, first I'm going to put my tube into here. So I've got my tube with the mark on it. I'm going to push it through this ferrule that has a little rubber bushing in it, and I'm going to let it stick into there about an inch, but no more, because I don't want this to touch the oil that's in the bottle once we start filling the bottle. So roughly an inch. I tighten it, and you can see that my pump, I've labeled it for oil. I use a separate pump for oil than I do for coolant, because again, we don't want to run the chance of cross-contamination, or we want to minimize it anyway. So now I've got my tube in there. I've tightened my ferrule so I get a good vacuum seal on it. Now I'm going to stick it into the tube for the dipstick up to that mark right there. I'm going to screw on my sample bottle, and I'm going to give a couple of pumps, and you can see the oil coming out, being drawn in by a vacuum into the sample bottle. And we want to fill it about 2/3 of the way. It does not have to be filled up completely. That amount right there is probably enough for the lab to work with, but we're going to give them some more just in case. So usually about 2/3 of the bottle. And this pumps relatively easily because the oil is warm. And that's about it right there. So now carefully, I'm going to unscrew this, because again, I don't want the oil to touch the pump if I can help it. And once I unscrew it, I'm now going to turn this over and let some of that oil run back into the engine, and I will very quickly put the cap on that oil so there's no chance of any contaminants going into that bottle. Now I'm going to clean the little bit of oil that's on there, clean it off, so when I pull it back through, I'm not leaving oil on the pump. Ideally, if I do this the right way, no oil should touch the pump body. So again, we minimize the likelihood of cross-contamination. We'll pull that through. And if you're careful with this, you really should be able to do it without spilling a drop. It should work that way. It shouldn't be that difficult to do. Okay, so now I've got my tube with oil in it. Got my rag to keep it from spilling. And now I'll throw this away. I'll put this in a plastic bag, and I'll do the same thing for each engine, generator, transmission, and each other part that we might be drawing oil from aboard this vessel. One of the other areas that we need to be sensitive to when it comes to oil analysis is the way that we handle our sample once we've taken it. The jar itself, the containment vessel that it goes in, and the paperwork that goes along with it. Now, my approach is, as I'm taking the samples, especially if I'm doing it on a large vessel like this, and I've got a variety of equipment, 2 engines, 2 transmissions, 2 generators, hydraulic system, as soon as I screw the cap on that sample jar, I'm taking my Sharpie and I'm writing on the top of that jar what it is, just so I don't mix it up. Now, the paperwork's going to go with it. We're putting a label on that jar right away also that's got the relevant information. But once again, just as a quick visual reference, I can look at the top of 5 jars and very quickly see what I've already done, what might be left to do, and I'm not mixing up potential samples. Once that cap goes on, it's going to stay on anyway, so that's a good way to keep track of that bottle. The bottle's going to go into a containment jar like this that a lid will go on. Some folks put the report that goes with that, or the data that goes with that oil, inside that jar. You can do that, and I have done that at times. I also have done that, and I've had the jar leak so that the paper gets wet. Now, the sample paper usually will not be ruined by the oil. You can still see the writing on it. So that's not such a bad thing necessarily, as long as the paper goes with the jar. The label that is attached to the jar, though, is permanently attached. And so there's no chance of separating the data that you've recorded from that jar. The lab's going to get it. The document as well as the label have the same serial number on them, so there's not a lot of risk there. So I keep the paper on the outside of the containment jar just to reduce the likelihood of it being made illegible by really black oil, which could happen. The other thing is you want to make sure, obviously, that the lids are on these jars very tightly. If you fly with them, if you pack them in checked luggage, I would put all of this in a Ziploc bag just to prevent the likelihood of leakage with the pressure change, and I have had that happen. And the other thing to be conscious of is if the data that you send is lost somehow, if the lab says we didn't get it, or the data that you've given them is different than what they think they've gotten, meaning the report you get back has different information on it, you're kind of at their mercy. I like to keep a copy of the report that I've sent so I know exactly what I provided them. So if there's a mistake, I know whether it's my fault or their fault. And the way I do that, if I'm doing it on a boat, I don't have access to a copy machine obviously, is with an app on my phone, I can simply take a picture of this and turn it into a PDF, and now I've saved that until I get my report back, and if there's anything that seems abnormal, again, where I think the data may be incorrect, I can look at the one that I saved and compare it to the information the lab gave me. If there's a difference and it's the lab's fault, then I'm on a little bit firmer ground to go back to the lab and say, please input this correct information and give me a new sample. The onus is on them to do that because they've made the mistake. Following these rules means that the reports that you're going to get have the greatest likelihood of being accurate, and you'll be able to confidently act on that information. And that is our goal with oil or fluid analysis, is to have information that we feel comfortable with and that we know is correct and therefore can be acted on.